Today, we're going to be going into the Nanopatterning Cleanroom at Stanford University to learn how AI chips are made. And the person showing us this is none other than PhD student Hamish Carr.
I'll put on a beard cover.
I can't grow facial hair. Oh yeah.
A single particle of dust, a hair can really mess up the fabrication, so we want to make sure we protect our samples against any of that.
Hamish, tell me a bit about your research. What is it that you do?
Yeah, so I'm a fifth-year PhD student in material science, and my research is in a field called nanophotonics, which studies the interaction of light with very small objects in the nanoscale and use them in data centers for training AI models and making the hardware a lot more energy efficient. These are very tiny. You can see some like squares there. Those are probably like a fraction of a millimeter, but in each of these, there's actually hundreds of thousands of these nano antennas.
These effectively replace the wires in a big data center, and they just let the computers talk to each other using light instead of wires.
Yeah, and you can put optical fibers to connect chips to each other instead of these copper wires. Data centers globally account for around 4% of total global carbon emissions, so you can really get an idea of how power hungry these data centers are. I can show you a little bit of how we prepare these. We're going to be doing something called spin coating.
Okay.
So we have these film materials, they're called resists. In this case, it's an electron beam resist. It's usually in liquid form. For this, I want to do 3000 RPMs.
Okay.
Do you want to press start? And then...
Wow. Now we're putting a layer on the chip, very thin layer, very controlled. How fast we're spinning it determines how thick the layer is going to be.
Looks like our chip is ready to come out of the oven. Should be a nice film.
Oh, wow. Is it glass? What is the material?
We want light to actually go through them and transmit that light intensity, so it has to be transparent. That's why it's glass. We've written some patterns. You might be able to see some tiny squares, and you see some like reflective film.
That's very cool.
I'm going to put it into the solvent, and you're going to see the metal film actually kind of just disappear. This is how the actual electronic traces are put into silicon chips.
This is about to be a cool magic trick. Oh, wow.
This is a door for the main chamber. The metals are down here and the electron beam is coming from below.
Wow.
It's at very high vacuum. You would put your sample in here, and then you use this transfer arm to actually slide in your chip. It grabs it from here, rotates it to face down, and then you start shooting those metals with electron beam to evaporate them and coat them onto your sample. If we're going to have all these chips communicating with each other in data centers, and you can make that communication a little bit more energy efficient, in the long term, we hope that it can really save more energy, water, carbon emissions. The motivation is that you don't undermine all of the positive effects and promises of AI with its environmental footprint.
Hamish, it's been such a pleasure being here today. I got to see so many cool machines and learn some really cool processes.
It's been a pleasure showing you around. Thanks for coming.
Thank you so much for having us. Same time next week?
Same time next week.